This is the back page of the optimization morning review. So number 11, we want to construct a box whose base length is 3 times the base width. The material used to build the top and bottom costs $10 per square foot, and the material used to build the sides is $6 per square foot. If the box must have a volume of 50 cubic feet, determine the dimensions that will minimize the cost to build the box. So we're dealing with cost, but essentially it's volume versus surface area. So let's create the dimensions for this box here, this rectangular box. We know that the base length is going to be 3 times that of the base width. So I'm going to call the base width x. I'll call the length 3x. This is 3 times more than the width. And then I will have another variable to represent the height. So 3x, x, and h. All right, so let's deal with volume first. That's easier. So volume is just going to be width times length times height. So our volume is 3x times x times h, which is 3x squared times h. All right, so that's our volume equation. Let's look at our surface area slash cost equation. So the cost is going to be based off of the different value or different cost for each of the faces of this box. So let's start with the base, or the portion that's on the ground here. So the portion that's the base is going to be 3x squared. So that's the area of the base. We know that's 3x squared. We know the top is also 3x squared, and then both the top and bottom is going to cost $10 per square foot. So $10 per 3x squared square foot, and then 10 for 10 times 3x squared. That will cover the cost for the tops. All right. The smaller of the two vertical sides is going to be this x times h. So this face is going to be x times h. This side is also x times h. So we know that the size will be $6 per square foot. So 6 times the area of the sides of the side areas. So it will be 6xh for one side, and then the other side will be 6 times xh. Now, the larger vertical sides will be this face here, so it'll be 3x times h, and then for the back face is going to be 3x times h, and then that will also be $6 per square foot. So 6 times 3xh, 6 times 3xh. Now we have cost associated with all 6 faces of the box, and then we can just look to combine like terms and clean this up. So all the terms without h's we can combine to be 60 x squared, and then the smaller side becomes 12xh. This becomes 36xh. Continue to clean this up. We get 60x squared plus 48xh. We're trying to optimize the cost, so we want to get our cost equation down to one variable. Looks like h will be the easiest one to replace. So to help us replace h, we're going to go back to our volume equation. We know the box is going to be 50 cubic feet, so we can replace 50 in for v and solve for h. Divide both sides by 3x squared, and we get h is equal to 50 over 3. 50 over 3x squared. Replace 50 over 3x squared in for the h of the cost equation. And now we can try and clean this up and prepare this to apply power rule. So 60x squared is ready to go. All this combines to be 800x to the negative 1 after the x squared comes up to the top. Now we can find the derivative. So 60x squared becomes 120x. 800x to the negative 1 becomes negative 800x to the negative 2. We can find the derivative, which we did. Set the derivative equal to 0, and then solve for x. And we get x is x cubed is 20 over 3. If we take the cube root of that, which is roughly 1.882, so then the dimensions will simply be 1.882 as as the width of the base, and then 3 times that will be 5.646, and then the height we can find by plugging 1.882 into the height equation, and which is 4.706. And then the minimum cost will therefore be whatever the cost is after we plug everything in. So if we plug in 1.882 in for x, and 4.706, and for h, we can find our cost equation, which will simply be $637.64. All right, number 12. There are 50 apple trees in the orchard. Each tree produces 800 apples. For each additional tree, the output drops by 10 apples. So this is another problem that we've seen before, where we have an increase in a value will be a representative decrease in the other value. So that's what happens here. We start with 50 trees, but for each tree that we add to the garden, we're going to lose 10 apple per tree. So once we have that expression, we start off with 800, but each time we add a tree, we're going to keep losing multiples of 10. All right, so now we have everything already in terms of x. We just have to clean this up by expanding everything through. Once we have expanded everything through, we can find the derivative. 40,000 goes to 0, 300x goes to 300. Negative 10x squared becomes negative 20x. All right, this should be negative 20x. Okay, so once we have negative 20x, we set that equal to 0. Once we have that equal to 0, then this should technically be negative 20x. So if we factor this out here, we get, all right, so I forgot to put 20x here, but this works out as 300 minus 20x. Factor out the 20, we're left with 15 minus x. Solve for x, we get x equals 15 trees. So we know the optimal situation will be where 15 trees are added to the orchard, which means that there's going to be a total of 65 trees. So 50 plus 15 is 65.